is Axiom Shadows, where we uncover the hidden magic behind everyday things. Today, we're melting down sand itself to reveal how glass is made. Glass is everywhere, in skyscrapers, in cars, in your phone screen. It's so common that we forget how remarkable it really is. This transparent armour can handle blistering heat, heavy pressure, and even blunt impact when reinforced. But scientifically, glass isn't a true solid. And it's not a liquid either. It's something in between, an amorphous solid. Its atoms are arranged randomly, like liquid frozen in time. Different mixes give us different kinds of glass, from soda lime, the type used for windows and bottles, to borosilicate, the heat-proof kind used in labs and kitchens. Engineers even make Gorilla Glass, the stuff protecting your smartphone right now. Legend says glass was discovered by accident, when ancient fires melted silica-rich sand mixed with ash. Ancient Egypt turned it into beads and ornaments. Then the Romans took it further, inventing glass blowing, the first step toward mass production. Once mixed, it's time to fire up the heart of the process, the furnace. Inside these furnaces, temperatures soar past 1,500 degrees Celsius. The ingredients fuse together into a glowing liquid river, thick, smooth, and fiery bright. This is where art meets engineering. Back in 1952, British engineer Sir Alistair Pilkington invented something that changed everything: the float glass process. Instead of pouring molten glass onto flat tables and grinding it endlessly, Pilkington had an idea: float it on a bath of liquid tin. Pilkington's discovery was genius in its simplicity. Glass, when poured onto liquid tin, floats perfectly because it's less dense. The result? A flawless, mirror-smooth surface. No grinding, no polishing. The molten glass spreads naturally across the tin, self-leveling under its own weight. As it moves along, it cools just enough to become solid, but still flexible enough to shape. This single innovation, the float glass process, revolutionized architecture, cars, and electronics. Nearly every window you've ever seen was born this way. Inside the tin bath, temperatures reach over 1,000 degrees Celsius. Hydrogen and nitrogen gases flood the chamber, keeping oxygen out so the tin doesn't oxidize. The glass floats, glides, and stretches into a continuous ribbon, moving at about 10 centimeters per second. It looks calm, but every fraction of a degree matters. Next stop, the annealing layer, where the magic of controlled cooling begins. If you cool glass too quickly, it shatters. So it must pass through the annealing zone, a long tunnel where temperature drops gradually from 600 degrees Celsius to room temperature. This slow, even cooling relieves internal stress and prevents warping. This process takes anywhere from 30 minutes to several hours, depending on the thickness. At the end, the once molten river emerges as a flawless sheet, clear, flat, and ready to be transformed. Precision cutters mark the surface with microscopic lines just deep enough to guide the split. Then a quick snap, and the sheet divides perfectly. Even defective glass isn't wasted. It's crushed into cullet and sent back to the start of the process. Nothing goes to waste in a glass plant. Ordinary glass breaks into sharp shards, but tempered glass, that's another story. It's reheated to about 700 degrees Celsius, then blasted with cold air. This creates surface compression, locking in immense strength. Tempered glass is up to 5 times stronger than normal glass, and when it breaks, it crumbles into safe, rounded fragments. That's why it's used in car windows, shower doors, and even skyscraper panels hundreds of meters above ground. Laminated glass adds one more layer of protection. 2 sheets of glass sandwich a plastic interlayer, often PVB. If it breaks, the glass sticks to the inner film, staying intact instead of falling apart. That's what keeps your car windshield from exploding into your face during an impact. From hurricanes to explosions, laminated glass saves lives every day, often unnoticed. Glass isn't just industrial, it's art. Add iron oxide, and it turns green. Cobalt gives it deep blue hues. Gold, a rich ruby red. From medieval stained windows to fibre optics transmitting light across oceans, glass is a bridge between art and science. And with nanotechnology, researchers now create glass that can bend light invisibly, repair itself, and even display digital data. The beauty of glass, it can be reborn endlessly. Melt it, reshape it, reuse it, without losing quality. Every bottle you recycle could become part of a skyscraper, or the screen you're watching this video on right now. From ancient desert sands to tomorrow's smart cities, glass is still the same miracle of melted earth. From the first spark of fire on sand to the shining towers that define our world, glass is proof that even the most ordinary things can hold extraordinary power. This is Axiom Shadows, where we turn everyday materials into stories of wonder. Thank you for sticking with me this far. If you love seeing the science behind the world's invisible heroes, don't forget to like, share, and subscribe. I ask that God bless you and your home, and that you are always well. Until next time, stay curious.